Hey.
Hello, everyone. We are just ready to get started. I'll let a minute pass or so people can drop in. Okay, and I'll go ahead and tweet some. Okay, so there we go. I will go ahead and just start with introductions. So, hey everyone, and welcome to another Relay Meetup. This time I'm trying out some brand new streaming equipment, gear-ish software. So if things kind of move around on the screen, it's just me trying to get this working the way I want. My name is Gabriel. I work at a IT consultancy in Stockholm, Sweden called Arison. We combine consulting with building startups. And with us, we have a pretty special guest who's returning. Was on the first meetup ever. And today we're going to talk about, basically Apollo and Relay and how they fit together, I guess, and how you can apply lessons from one of them on the other and so forth. So without further ado, maybe if you'd like to start by just introducing yourself, and for those who don't know you already.
Yeah. This is classic me at the last minute, actually putting together slides. So hey, I'm Eloy. Eloy Durán. Eloy on the internet. Let's see, what can I say? I've been around the open source blog for a while. I might have made your life horrible with CocoaPods if you're developing iOS or macOS applications. Been using GraphQL since early 2016 at Artsy, and always try to do that in open source. And have used Relay since the start. Otherwise, let's see, I am currently at Microsoft, working on Teams, and I live in Amsterdam, and behind me you see what the view of my houseboat used to be when I lived in a houseboat until this summer. Yeah, 2 kids, a dog. Dog is here. Perhaps she'll make herself known at some point. And otherwise, I brought all my relay swag, right? So yeah, we're all good.
Yeah, please, Relay core team, we need swag.
Otherwise, I will. Yeah, this is how I will present.
Yeah, that's the only tech shirt you had. So I mean, what can you do?
Yeah, exactly. You don't want to have me show up naked.
Yeah. Yeah. So you have a couple of slides that I think we could start with.
That's so. Yeah, let me just let's see. So these slides are from a discussion meetup, very similar to what we're doing now, that we had recently at Microsoft, and it's about just 2 GraphQL clients that happen to exist. Right? There's in the JavaScript space. There's others, of course, as well, but these are the ones I know and or use. And so it's a comparison about the 2. Let's see. Yes. There we go. So professional. Okay. So GraphQL clients, or at least 2 of them. Quick, we already did this about me. Oh wait, I'm not this. This is not correct. I need to do. Where's this one? Yes. Okay. So me, we already did that. Eloy, GraphQL since 2016. I'm contributed I have contributed to Apollo various things, but I think the most relevant, notable thing here is work that allowed their VS Code extension to be used with the Relay setup. And I contributed to Relay. Things that people might have used is adding the language plugin feature, which really is just kind of a hack of exposing some of the internals, and then implemented a TypeScript plugin because, so when we at Artsy started using, so very quick background, at Artsy, I was working on the iOS application, fully native Objective-C at the time. We realized that was not going to scale because we were always going to have a small team, and we were interested in looking at different solutions, especially ones that could pull in the web developers. That was early days for React Native, but we spoke with some of our React Native Facebook friends and felt comfortable enough trying to give that a try. And so then we figured, let's not make things hard on ourselves because we have this entirely different setup for all our Objective-C developers. So let's just at least have things be coherent. And so, we started out with React Native, Relay for GraphQL, Flow as the language, and also Atom with the Flow setup. Nuclide, I think is what it was called.
Yeah.
That didn't work too great for us. I think it felt like you needed a team to keep it up to date and performant and running, and configuration was just a little opaque. So at some point we heard a lot about VS Code. Figured, well, let's give that a try, and that felt nice. And then okay, well, let's give TypeScript a go then. And that's pretty nice how it works together. Not much configuration. So we quickly switched to that setup. And so that meant, of course, that we initially were doing Relay without any type generation and whatnot. We were manually doing some stuff. And then at some point, enough was enough. So that's why we contributed to the TypeScript plugin and the language plugin feature. Not just us. There were great help from people in the community. So that is about that. Let's see. Okay, so first let's talk about Apollo, right? So Apollo, or better put, Apollo Client, because Apollo is the name of a company. So Apollo Client is created by a startup that sells GraphQL server products and services. Right? There's no secrets there. That's what they do. They need to pay their bills. They have lots of community materials, such as great documentation, or just even people around, right? Channels full of people, Stack Overflow, people everywhere using Apollo.
Users.
Yes, users and excited users, right? That wants to a vibrant community, right? And Apollo eagerly accepts community contributions. They want to work with the community. That's part of that vibrant community aspect, right? And then they want to be flexible so that they can adopt to most projects' opinions. They definitely want to be a good option for a brownfield project or just any project where the developers feel like we know how to architect a project. Now we just need something that can melt into our architecture. I would say, I don't know if they would put it themselves, but I think for me it's pretty clear and not in any way dishonest or something, if somebody would think that, but the Apollo Client is their foot in the door, right, for you as a customer. And so for that to be the case, it needs to be as low barrier as possible, right? They want everybody to be able to use it. So for instance, that means it will never require a build step, right? Because for lack of better examples, I'll just say, let's say you're putting together a marketing page and for some reason you're using GraphQL on your marketing page, and then you probably don't want to have this whole build set up. Like maybe you took care to write vanilla JavaScript so that every browser can run and you don't need to compile anything. So that, good on you. Then this can work for you, right? On the other hand, most projects that I end up working on, especially at the scale that we have, like at Microsoft, not having a build step is not one of the things that we really need to care about. Like there's going to be gazillions of build steps. And with Apollo clients, the unit for a targeted UI update is a whole query. So that means that if we think about the flux pattern, I was too lazy to create a diagram about the flux pattern, so I'm just going to assume that you know what it is. But let's assume like you have data, you have state, your UI reflects the state, right? That's the whole React little funny function thing. So function of state, right, is the UI. So whatever is your local state, which is kept in the client's store, is what you want to have reflected on screen, meaning that when you make changes to the data in the store, you want the UI to reflect the new changes, right? So with Apollo client, that means that any of the data change that you have selected in a whole query, if any of that data changed in the store, then from the root where you executed that query operation is where the UI will re-render. So just keep that in mind, right? As we'll get back to that. So then there's Relay. Relay is created by Facebook for Facebook.com to be as performant as possible. That is what Relay is, right? It is not for us. It is for Facebook.com.
Yes.
And I think there's what often happens is that people. Open source is this term that means different things to different people. To some people, it means social coding with stars and whatnot on GitHub. To other people, and I guess that is also like a vibrant community of people, right? Like it means more than it means more to them than that. Like, but open source with the capitals, like that is basically just legalese that none of us really want to deal with. But it just means you can use this under this text, and that's it, right? And that's what Relay is. Relay is open source in the sense that they have open sourced what they need, and they will keep building what they need. And people that want to use or can use Relay can benefit from that. Sometimes it means that we might end up making Relay slightly better for them, but odds are that that's not really the case, right? They know what they need. And that's what they're putting budget against. So Apollo client created by a company that wants to have you as a customer. Relay created by Facebook that in the nihilistic sense doesn't care about anybody else, right? That's not to say like the people on the team, like they are great people, and I know they would love to be doing more of the vibrant community type of stuff, but it's just a different scenario. So small community, great community though, and not so great documentation. Historically, it's definitely a lot better. I recently have had a colleague of mine say, "Yeah, I know nothing about Relay. Let me go read the documentation." Next day, said like, "Yeah, it was great." And came back with all these nuggets of details. That's great. There's some great docs in there about architecture decisions and whatnot, which I don't think are that easy to find. So he definitely took his time for it. But it is there. But you can. Now it's definitely better, but you can still notice, I would say honestly, that it is a second thought, right? Like it's a thing that when somebody has time, it gets improved, but it might be out of date. With all the best intentions, that's what we have. Relay does not easily accept community contributions. Some of my PRs have taken well over a year to be accepted. Some of my PRs to Apollo have taken a day to be accepted. So that's quite a big difference there. But again, it comes from the same types of perspectives. When I was building CocoaPods, for instance, I knew that I did not want to be maintaining and working on CocoaPods for the rest of my life. It's just a build thing. It's very boring, right? And so from the get-go, I invited people in, and made them feel owners of this thing together. And I was not going to be a dictator. Well, I was a benevolent dictator, I guess, for a while, but I was very strategic about making sure that I could at some point just step away and the thing could just live on. And I'm not saying that's the same thing here with Apollo, but I'm saying, like, there's good reasons to sometimes be very inviting and sometimes be very defensive. And in this case, like, again, it stems from Relay needs to be as good as it can be for Facebook.com, which sometimes means, some PRs need to be ran against benchmarks on like Facebook.com, and it just takes a lot of time, and they don't have that time necessarily. So it is, I don't necessarily think it's a bad thing. Like, some people might think, like, this PR has been sitting for a year, that's horrible, right? Yeah, but I can, I feel comfortable running a fork. So because I know what I need, right? And so as long as you have that ability, then Relay is fine in that sense as well. I'm sure that out there's a plethora of Relay forks that are subtle running, because they, I think at some point initially that was definitely also the idea that there was no need for plugins, because if you really needed something different, you would just build a new compiler binary that assembled the pieces internally, so that was kind of encouraged. Anyways, it is inflexible. It does not. How do I put this? I mean, it has its own opinion, right? You do it the Relay way or it's the highway, and that has gotten better. In the past, you could definitely not use Relay if you didn't follow certain requirements, but over time they have gotten rid of most, or if all of them. But a lot of the nice features that Relay offers are because it can make assumptions about your project, and so you're throwing those out of the window if you don't follow those opinions. I would say from my experience, the opinion about project structure leads to better scalable project maintenance. So these are things like co-location, data masking, right? And scalability is of project maintenance, I would say, is both about the size of your team, how long your project lives for, being able to relatively safely have engineers work on isolated pieces of the application without worrying too much about breaking other parts of the system is, of course, a thing that we always try to have. But that might not be what you need for your project, right? Like this, like if you have a small project or you're a group of two people that finish each other's sentences, like it might get in the way, right? Like it says just different types of projects. And Relay is ahead of the curve when it comes to React features. Like suspense, it was informed by Relay. It's not just like the Relay team was like, oh, this seems nice, let's use that. No, that's like it gets built together, and it's kind of unfair, I guess. There's no real way for others to to have that level that playing field. So that's just how it is. I'm sure that there's a lot of people that don't even use suspense today. So I don't even know what the status is. Is it still experimental? I don't know. I use these things probably way too early most of the times. Let's see. We did that. I think the main conclusion is the two clients have fundamentally different goals and are good for their goals. So it is not about comparing apples to apples and one apple being better than another apple. It is as cliche as it is. Use the right tool for the job, yeah, that's life.
Yeah.
So yeah, that were those slides, and I can talk about this for a long time. So I'll just pull the slides off screen. Oh, you can do it. You're the broadcaster.
Yeah. So where to start? I feel like there's so many. Like what when you came to Microsoft,
yeah,
and you started looking through because the setup at Microsoft now is it's using Apollo for Microsoft Teams, right?
Yeah. Shall I give a little? Do you want me to give a little bit of a
history around that? How this all got started?
So, well, very quickly. When I was when I felt like I had done my work at Artsy and it was time to move on, I was fortunate enough to be able to choose between a few locations, and one of them was, for instance, Apollo. But I chose in the end Microsoft because of their what they call the One Microsoft initiative, or it's a goal where we all work together, stand on the shoulders of giants. Like basically how I work, how I always like to work in open source, etc. as well. While I was going to start working on React Native in Office, they told me you can talk to anybody at Microsoft and work on anything. And so I spent a little bit of time figuring out what is the state of GraphQL at Microsoft, because I figured if I want to move the needle on GraphQL, then doing it from the perspective of Microsoft is probably gonna be good. Worked with a lot of people, figured out at some point that Teams is like where a lot of the action happens, and Teams is a giant within Microsoft. So a lot of other teams tend to just follow what has been proven out. And so Teams has GraphQL only in the client. So there's no GraphQL server. So there's an executable GraphQL JS schema running inside the client, which the resolvers they fetch data from all sorts of endpoints, and then there's Apollo client, talking to that local executable schema. So kind of awkward at first, but I have come to like it. Because it allows us to take a fresh look at how we can employ GraphQL. You can see like there in the little corner, there's like my co-worker that I was fortunate enough to also attract to Microsoft is Michael Novikov, known as Freixenet, I don't know how you pronounce it, on GitHub. And he's done like work as like, the early schema stitching, delegation, that type of stuff that Apollo and GraphQL tools exposed. And he organized a conference in Helsinki, I believe it was. And so the things that we have been, that it has allowed us to think about things like going back to like graph. I'm sure that you've seen many talks by Lee, for instance, where it's like GraphQL is a spec. Right? GraphQL is a spec, always being hammered on that, right? And it's nice to go back to think about it in that sense that it is just a conceptual contract between a layer of UI that wants data and a layer of providers that provide data. And so, for instance, we're looking at things like, so you use, I'm going to assume most people watching use Relay, and they're familiar with, for instance, persistent queries. And so with a persistent query and our setup, we can statically at build time know all the queries, also mutations, like operations, but let's just say queries for ease of naming, that the application executes, right? And so we don't need to treat that, our executable schema does not need to treat that as a surprise, like it's a server somewhere on the internet that could be hit by any GraphQL query. And so what we can do, and what we are looking at actually doing, is statically compiling those queries, so like the GraphQL execution away. So during development, you have more dynamic GraphQL execution, and you can build up your GraphQL documents. But then at compile time, it's, the party's over. We know what the query will look like. Relay will give us a hash, whatever, for the query. And we can basically just compile some JavaScript code that executes exactly the resolvers in the right order. And we don't need to have any GraphQL JS AST flying around the application the whole time. That's the North Star goal. Obviously we iterate, and for Teams itself, it's going to take a while before we get there, because actually we're doing work that this type of work will be applied to other host applications that start using GraphQL from now on. But that's the North Star goal. Like, we want to have a very flexible, that's the nice thing about GraphQL, right? For front-end developers, like, they can just build their UI and select the fields they need without talking to these pesky back-end developers. That's the picture, the easy, I jest, of course, but the idea that you can have, and we want that. But then at build time, it's just about the contracts and being able to provide that data. So that is one piece of it. Just looking again at the pure aspect of it being a contract, not necessarily an executable server. Like, most people tend to think of GraphQL as a server, right? And it happens at Microsoft as well. Like, everybody's like, oh, right, so you're going to move it to a server, right? Like, yeah, I mean, I guess, but maybe we first see what we can do with this. Because the other thing is, for instance, live queries, right? I would say live queries, to me, by now seem like the holy grail. Like, subscriptions are just awkward in many cases when you're building UI, and especially you want to have this isolated feeling, right? Like, you're doing your query, your fragments, all collocated nicely, all isolated, and suddenly it's like, okay, well, now I suddenly need to know about this data somewhere at a place that all of these components kind of want to know about, and then mutations are similar, but I haven't seen a great solution for that yet. But subscriptions can probably be deprecated for live queries, in our case, in most places.
Could you do a quick background on the definition of live queries and what they mean?
Yeah. So let's start with subscriptions, because people understand those, right? Subscriptions you use because you have remote state and you want to have local state that's up to date with the remote state, right? And so a subscription models an event, right? If you're familiar with JavaScript event emitters, etc., right? That, like, it models an event, and so from that event you can then update your local state, but it's not necessarily doesn't necessarily have to be like a delta of the entire state. It's just like, hey, somebody liked your photo, right? Whereas a live query also replicates the state, but it does it wholesome. It's like, I care about this whole query at any given time. I don't care about the individual events. I just care about the whole state at any given time. And so what you could naively compare that to is just polling the query, right? So you have a query and you just execute it every n seconds, and then your whole state is updated entirely, and you re-render the UI based off of that. So there are both ways to replicate state, but one models events and one models the entire the state as a whole. And so live queries are not something that is spec'd out. It is a thing that Facebook said at some event that they do, and others have started doing it as well based off of that. Yeah, I think it is obviously not a thing that is easily done. Subscriptions are easy to understand. If you have, for any smaller company, you can have a server that, you're going to run WebSockets. That's already that's the whole thing already, right? But at least the things you're sending over are understandable, smaller events. Live queries, they kind of require the remote server to be stateful and understand, this is all of the data that the client asked for, and then keep that up to date, right? And so that's not something that you deploy that easily. In our case, the remote server is local. So we should be we don't need subscriptions for that. For the aspect of simply modeling small events. For us, it's much easier to have a stateful GraphQL execution engine. So that's something that we want to do. That's what we want to have. Rather than having all the product developers set up many subscriptions to just a different thread, like in a web worker, we just want to have all queries basically be live. So any component can just say, this is the data I want. That's the end of it. Just make sure it's always up to date and re-render me in the most efficient way when that state changes. And that also allows us to do things like, when you launch teams, you don't necessarily want to execute all of the queries at that time, right? You want to be deliberate about deferring queries until they are really necessary. And so right now, that kind of leads to the product developer to know when they are allowed to start rendering their component, because it's all fetch as you render. So the product developer has to think about when do we start rendering, and then rendering implies fetching. And I think that should all be framework stuff. The product developer shouldn't need to think about this. The product developer should just develop a component with data requirements, and then leave it up to the framework and the application to decide okay, that's great. Now is the time that I'm going to give you this data, and then you're just going to do the right thing, right? Yeah. So that's the type of stuff that I feel like we have much more freedom in with this local GraphQL schema. Once we have that all figured out, I'm fine with it being a remote server. I don't really care about that. Yeah.
So looping back to you enter a position at Artsy, you started Microsoft, you kind of poke around and you find the GraphQL. This is where you want to try and develop things further. You come to Teams, you have a look at the code. Coming from having used Relay for so long, what are the types of things that you see that you want to try and work on? Kind of, what are the biggest things that you with your Relay goggles on see?
Yeah. Well, look, to be honest, I want to be doing things that start where Relay ends already. The things that Relay and the Relay team have already figured out, proven out, are, I think, the good choice in many cases that we have. And I kind of don't want to have to redo that, right? I want to work on things like building out a live query setup that works for us. I want to work on data-driven dependencies, you know, and having that architecture set up. I wanna work on novel things that we need that, you know, Relay would provide a good foundation for. But unfortunately, you know, life is as it is. Like you don't get a greenfield project every time, and in this case, you know, there is Apollo client was being used, and as I alluded to in the slide deck with the unit for updating the UI, Apollo being you know, the whole query being the unit makes it so that we kind of are dealing with problems that in my mind were already a solved problem. Right, so what that meant in the end is that at some point, the end of the summer, I would think, a group was spun up to look at re-rendering within Teams. And out of that, organically, people figured out on their own a way to manually have a large query, which they call the fat query, not to be confused with what Relay Classic calls the fat query. But basically, what we know as the root, the operation, right? Like at the root where you invoke the operation, and then have multiple smaller observables. So in Apollo parlance, that means like we have a query, use query. Let's just use React hooks for that. Like use query at a root place somewhere, and then there's multiple watch queries that watch smaller pieces of that query, which is fragments with Relay, right? So they arrived at this architecture being a good solution, which is what Relay already does. And so with them figuring that out, us getting together, you know, I realized a way that we can have this we can bring some of that to our existing situation, right? Because manually doing that work doesn't scale, of course, and it puts it again back into the hands of the product developer, and it should be a framework thing in my mind. And so we started implementing the Relay hook APIs on top of Apollo client, right? So starting with use query is use lazy load query, because we need to start instilling the sense of not that what we have currently is fetch as you render, and that what we want to have, what everybody wants to have, but they don't know the term necessarily for, is render as you fetch. And so use lazy load query, and then obviously use fragment. So those are the first few, right? Like we use the code that we have in our branch is, if you were to look at it, you would, at a glance, you would think it was Relay. So that's like use lazy load query, and that's use fragment. Under the hood, we use a Relay compiler, but we have a new, we proxy it with, like, we have a new binary that pulls together. We monkey patch in, like, right now some of that stuff is really hacky, but it's just, we monkey patch some of the transforms. We add some more transforms, and what we do is we compile similar to Relay, except, for instance, we emit GraphQL.js AST, because that's what Apollo client needs. Right? We don't emit the IR that Relay otherwise emits for Relay runtime. We similarly extract metadata about a connection and encode it into the artifacts. We have now used refetchable fragment, and that works similarly. But what they do, what they all do, is what we call, so we have execution documents and we have watch documents. And the execution document is what actually gets executed at the root. It fetches the data, it populates the store, and then everywhere where use fragment is used, it under the hood uses Apollo client's watch query to execute a query against the node field, except it never actually hits the server. It, like with Apollo client, you can have type policies for fields, and you can basically fetch any data from the store that you would want. Like, so from the node field, we actually just take the fragments that were part of the whole query and just fetch that piece of data out of the store as if that was an actual query that was legit to be ran. So yeah, it works. That's like thus far. We have people that are very that look very heavily at the performance of things, because that's why how this whole effort was born. And they have not found any red flags in this approach yet. So we are going forward with that. And so that means we're going to fragmentize the rest of this, at least initially the chat pane, the chat components. And at some point I will want to take that opportunity to run benchmarks of Apollo clients and Relay runtime. At the very least, just because it's going to be the most honest comparison that I will ever be able to witness. But perhaps it's if it's going to be more performant, then let's just do that, because then it also means I don't need to, or we don't need to keep re-implementing stuff based on the compiler and in the client. And some of these things are also we're building out the things we need, and there's probably going to be some features in Relay in the hooks that we are skipping over right now because we don't need them. Like I don't want to be necessarily in the business of replicating something else. And actually, the one Microsoft thing says this, right? Like we should use what exists or add to what exists first. Replicating a thing is not necessarily what we are in the business of. So that's where we're at. Like, the important thing I think for us is it's going to be such a huge difference to have a fat query and then small observables rather than a waterfall of queries, right? Because that's what ends up happening with Apollo client. If you at some point want to have these smaller observables, you want to cut down on re-rendering your entire tree, you end up just making more smaller queries, right? And that's a waterfall, and a waterfall is not great for various reasons. Among others, it doesn't really allow for a great way to design your loading experience, I would say. If we are able to hoist all the data that a piece of UI needs to a single top-level query, and then deliberately put in place things like defer or stream, right? Then we can actually, and then use suspense. Then we can actually show we can have a stable, reproducible way of loading the UI rather than whichever JavaScript code ends up happening running first, right?
And just to sum it up for the people who are on here who are used to Relay, so basically what you're going for now is kind of the hooks version of the old higher component APIs, where there's no suspense or anything like that. It's more the query loads in its entirety, and then you delegate the re-rendering experience basically to the fragments.
Yeah.
But there's no suspense, and there's no partial rendering and those types of things either. There are in the newer versions of Relay.
No. So yeah, that's what I meant, right? Like this, that's a big step up for what we have.
Yeah.
And so that's great. For the stuff I, as a person, as an individual, want to work on, that's obviously feels like a step backwards. Like it's something that was already solved. Yeah.
But I think it must be quite a nice experience because going back to Relay and Apollo and the differences, one of the absolute biggest differences is just that thing that you're talking about, like the unit of re-rendering, like where does the re-render actually happen? And this thing solves that thing. Like even if it doesn't have the other kind of the suspense and whatnot.
Yeah.
And I believe like that re-rendering at the right complexity, or whatever you want to call it, that's maybe the biggest benefit for a large code base, especially something update heavy like Teams, where things are happening all the time.
Yeah.
It's nothing if you have a read-only kind of ish experience.
Yeah, exactly. Yeah, this is a pain point that I think inevitably of any project that comes to a certain scale that's using Apollo client will have to deal with. That's just the way it is. With some of the choices for simplicity comes this cost, which is that flexibility and not wanting to impose opinions on your project. It is now on all product developers implementing all components to consider how they are passing along this data through the tree. Whereas I think, that should be a framework concern. Like some of that data should never enter the tree at certain levels. It should just enter the tree where it's needed.
And how does that work? Because you do still have a fat query, so to speak. How are you just blocking that through normal re-render blocking? So that, like, because I guess that query must still listen to updates to itself, and it must include everything.
Yeah. So look, with relay as well, you're not gonna be able to avoid if you for the sake of argument want to have a tree that never re-renders anything that it shouldn't need to be re-rendering, then with relay as well, you'll have to insert things like React Memo at certain places, right? The question is, of course, whether or not they are necessary in some cases. But if you want to avoid any re-rendering, then you would have to do that with relay as well. The point is more that they are better understandable about where to insert them. Whereas the other approach with Apollo client kind of tends to lead to people just inserting memo all over the place. Because you just have this big bag of data that's nested many levels deep. You're gonna either pay a hefty price comparing nested objects, or you are just gonna memo everything. Like it's that if you have smaller objects, smaller pieces of data changing, then you can be more deliberate and about where you put these optimizations. So with relay, you have the same situation, but you can some data never needs to hit, definitely not siblings, right? If you have a list of things, for instance, you never need to hit any siblings because you're only starting at a single item in a list. But if something changes at the very root, then yes, you're going to be re-rendering the component at the root. But hopefully the fragment at the root of the document in your query is so small that you'll be able to easily guard against re-rendering children.
And summing up the compiler work you talked about, so you've done things to the relay compiler that makes it output the graphical JS AST, like, so basically what the graphical tag library coming from Apollo does at runtime, I guess. Otherwise, it parses the query and.
Yeah, well, so I think if you're using Apollo client, then the one thing you're familiar with is just if you already have a build step, just at least parse your documents ahead of time. Yeah, right, and then include the GraphQL.js AST inside your bundle rather than a string document that you still need to parse at runtime. So that's what we do as well in the compile transform. But we also do all the other things that relay would otherwise do. So optimizing some of the queries, right? Like we still. Well, what we do is like in this case, really, really simple. If you have ever looked at your artifacts that relay compiler generates, then and your operation artifact files, it prints like a text version of the operation for your convenience, and we ignore the IR that it gives us, and we just take that document, which has been optimized, and we just parse that as GraphQL.js AST, and put that in the artifact instead. Let me just quickly pull up a.
It's clever.
You
are known for being clever, though, so I'm not surprised.
More so in like, this is a simple, nice way to do it.
Yeah. You're like having headaches over like, I got to convert that IR to the graphical list, and then you see the screen.
Yeah.
Wait a minute.
I've definitely considered things like that, and luckily I've done it. It's all those hurdles when once passed, things are actually quite nice and easy to do, it's actually quite fun to implement some of these APIs that you have taken for granted, because you learn to appreciate some of these things more. And also something like the mock payload generator, right? Just porting that to GraphQL.js is why didn't this exist yet? It's seems so obvious, but so that allows me to have a bit of fun for something that's actually needed. Yeah, so everything, of course, is open source. I wouldn't do it differently. So if you can share, can I share that screen? Stop sharing. Share screen. Window. This one. Yeah, can you see it? I'll increase it.
Yes, let's see here at the stream. Yep.
Yeah, so the repo is github.com/Microsoft/gravitation with PH.
Nice.
And the branch I'm working in is the Apollo Fragment Store Watching. Great name. Let's see, and then in here there's an example which has some of the artifacts, because I check in artifacts. So here's the instance, and these are the types that you're familiar with, right? And obviously we want those, so that's already one reason that we want to leverage the Relay compiler. And then this is that comment that I was talking about. So this is a query that Relay compiler has optimized if it needed optimizing in any way. It has also, so this is another thing, right? Apollo client will by default normalize data coming into the store by the ID field. But it doesn't want to have an opinion. It wasn't impose an opinion. So you can use other fields, even multiple, which is then you have to specify through their type policies, key fields. But also because there's no build step, they can't really, I guess they could do it at runtime, and they do for type name, but otherwise they don't inject these selections for you, right? That would make normalization stable. So it's a thing that trips up people all the time. So Relay compiler, obviously, if your object type has an ID field, it will select it for you, right? So that's that's also in this document. So we don't need to do that stuff. And then we just take that document and we parse it as GraphQL.js AST, which is this. And so we can just directly feed this document to Apollo client to execute, and it will. This is the entire operation, right?
Yeah.
So that's the fast query. Right?
Apollo then prints that as an actual. No, right. You have persistent queries, of course, but otherwise Apollo will print that as an actual query. Or
well, no. In our case, it passes that AST as is to GraphQL executable schema, which also needs AST, right? So there's no more transformation done there, at least.
Yeah.
But yeah, this is essentially what it conceptually passes to Apollo client, and Apollo client passes it to the schema execution. So this is the whole query, right? But then that's not what we want to watch, right? We want to watch smaller pieces of it. So let's see, is that? So in this same file, like if Relay, right, let me go back for a second. So Relay, so that if you look at the app component at the root, this is where we have the query. It's composed of these other fragments, and actually this interpolation is gone now as well. This was when I was still trying to have it work fully dynamic at runtime, but yeah, that's going to go away. So this is going to look exactly like Relay. So you have this query with fragments spread in. So you know that it makes up a larger query that needs to be executed, but really this component only wants to know about this data, right?
Yeah.
And so if we look at the generated artifact, then there's this whole execution query document, which is the whole thing. So please fetch all of this data and put it into the store, but don't give me that data. Instead, execute a watch query with this tiny, cute little query, and only give me that data, and only notify me of changes to that data. I don't care about changes to the other pieces of data, right?
Interesting. Yeah.
And so this is a much smaller document then. And then the fragments, they, no, let's see, the query fragment, they do the same. So this is the fragment for this component. And then we basically just emit a refetchable query, which queries on the node root field, and then for that fragment. And so that's what this document looks like. So after executing the fetch query, all of these little watch query documents will immediately resolve from the store because the data has already been populated into the store, right? And then only whenever, what is it here? The uncompleted count changes, this call site for use fragment will be triggered. So yeah, that's how we do it.
And what about like cache policies and whatnot? Because you had the underscore fragments thing there, which you also mentioned does a bit of magic to pull out the actual data from the store. Like, do you generate those things as well at build time?
No. So basically, what hands up happen? No. So look, with Apollo client, so with Relay, there's Relay never wants to. It doesn't even have code for some things to be possible at runtime, because anything that can happen at build time happens at build time and can never happen at runtime. Whereas Apollo client needs to be fully dynamic and can do anything at runtime. And so, so at the core, even if we are rebuilding some of these APIs, at the core, Apollo client will always have a dynamic nature versus a static nature of Relay. Yep. Right? So the things that you're thinking of that Relay would do ahead of time, create a selector document, that type of stuff, that doesn't exist. It's basically just, it's exactly this query gets executed, but then Apollo client will, let's see, that's not going to be helpful. What we do is we have this type policy, field policy, in this Apollo React Relay duct tape package, which here it is, node from cache field policy. So what it does is it captures any query for the node root field, and then it takes the fragments, the fragments that it received, and just tries to read those from the store, because we know that that data should exist in the store by that time, and so we just return that. So it's dynamic, right? We like the fragments are available, of course, and they are somewhat optimized by Relay compiler, but otherwise it's still dynamic. And actually, I'm probably not going to keep using the node root field for this, because it just feels awkward. We'll just introduce a new underscore whatever field that is meant that's meant to just serve this type of preceded data. Yeah. Some other interesting. So, like I said, like we do. So here, by the way, is where those transforms live.
I didn't know this was open source. That's really nice.
Yeah. And
should have guessed with you though, but I mean, it's
open source by default. If it doesn't need to be closed source, then it shouldn't be closed source.
Yeah.
So here we have some compiler transforms. Let's see what is interesting. Annotate. Well, there's fun stuff in here. I think And it's also fun in the sense that some of the things that you might like they are conceptually similar to Relay, but they are simpler, right? So if you look at the example artifacts, then for that's not in here yet. So for pagination, for instance, you'll just very clearly see how we are passing around the operation variables and how we are extracting the connection metadata. Whereas if you look at the Relay artifacts, that's a little bit more opaque than IR. It's simpler, and so it's easier to grasp some of these things, how they work under the hood.
Yeah. And I guess with the dynamic nature, it will be hard to, or maybe you've already looked at that, but replicating things like arguments and argument definitions and those things for the fragments.
Well, I haven't tried them yet because I learned that I never got to use Relay hooks in earnest in production. Mm-hmm. Because last time I was using it in production was towards the end of 2019, and that code base was fully HOC.
Yep.
So I learned from documentation mostly that the argument definitions directive is not heavily promoted within the hooks, at least. More so just like, just reference a variable, and then Relay compiler will tell you it needs to exist at the root of every query, of every operation. So that's what we're doing right now. But when I did try to enable it, I think it kind of just worked because, Relay compiler will just rewrite the query, right?
Yeah.
So to us, it doesn't really matter. We just take whatever Relay compiler gives us and reparse it. And so I think it will just work, but it's mostly for now, I think it's just gonna my experience with argument definitions is like as a developer, it seems like obvious that you would want parameters to your little fragments. Mm-hmm. But for some reason, to people new to a GraphQL co-located fragment relay system, they're just extra stuff they need to learn, and they manage to build an application without it just as fine.
Yeah.
So
I think like with the new hooks APIs and especially around like pagination and audio generating pagination queries and those things, it kind of nudges you more into thinking about a fragment as its own unit for real, and in that sense it makes more sense to also have the fragment define its variables and have default values for those variables and whatnot, and that you can render the same fragment in multiple places in your query or your application and apply like a single variable value statically, for instance, and those things, and the compiler just takes care of it.
Yeah,
it's my experience.
I don't disagree. That's like that. That is how I definitely used it during the HOC time as well. But I kind of sensed that people, if you don't use argument definitions, then the compiler will just tell you this is what you should be doing, and so you'll just add it there, and it works, right? Like it's not fully isolated, and that's less nice. But it's also sometimes you need to pick your battles, and right now we just have a huge code base that needs to be pragmatized first.
Yeah, that's not where the big wins are going to be. Argument definitions and arguments. But yeah, again, it's so nice that this is open source. I'm going to go in and have a look through because I've been using Apollo quite a lot as well recently, and it is very interesting to think about and poke around in what actually goes into all of the hooks in Relay and everything around that, especially around fragments. And like I said before, I think like the fragment part is really the biggest win for most applications, probably. The re-rendering, like just having that fixed, as you said, like this is a solved problem in the sense that like this is not something that you're used to having to worry about re-rendering performance. Or if you do have to worry about it, it's as easy as breaking things into smaller pieces.
Yeah.
So
I think having fragments is one of the biggest wins, period. Even if it even if it wouldn't allow for these targeted render updates, like having fragments co-located with their components. Like I said, for the the project maintenance, the scalability thereof, I think that is the biggest win using GraphQL with your component tree. That's how they glue together nicely. And then it's great that obviously those are primitives that we can use to build up like a framework that can be efficient.
It's also like, we're not talking that much about new APIs, but it's quite interesting that it's both an excellent unit for re-rendering, but also a good unit for suspending, like with partial rendering, that like you can let Relay work its way all the way out to a fragment and then have a look at the data and then like suspend or let it render depending on with all data, depending on what's in the store. And that I find that, yeah, the fragment is so nice because there are many things that they're like just make sense with it.
Yeah, exactly. Yeah, that's not suspending, but like things like the design loading experience, like defer, those types of things. It's also being a topic that comes up a lot in internal discussions, because once you have a query, that's where it ends, right? Like your composability ends there. You can't recompose that into a larger tree or whatnot. And so if you have fragments with components, then you can keep composing them and then be smart about how you want to load these things individually. So yeah, fragments are sorely overlooked sometimes, I feel like, and they are mostly when they are used in a non-opinionated scenario, they're mostly used in a way to like keep code dry, not repeat.
Yeah, dry. Yeah. Just typeless is how they're used typically.
Yeah. That's I think that's one of the one coworker at Artsy at some point put it well, like you just need to teach them that sometimes it's fine to have noise or like to have garbage, like where some engineers would just feel like, oh, we can't repeat this, we should put it in a shareable place. Like, no, just put it in a single file. Don't export it, keep it local to the file, duplicate it. You shouldn't even need to know that it is duplicated, because that's the whole point, right? The whole point is that you need to only think about this isolated piece rather than the whole system. Yeah, I think that's the most overlooked thing about fragments.
Yeah, no, I agree. It's really, and that's, I guess, what draws, well, I'm not gonna say a lot of people, but the few people who are here in Relay Land, what drew them here is at least often like the thing that really, and like GraphQL and with Relay is really what React is for UI development, but for data, kind of, that you have components, they are reusable, you apply them in certain parts of the tree. It's virtually the same, but just in the data layer instead, which is why they work so well together as well in practice.
I agree. It's just so unfortunate that 9 out of 10 times this realization comes after the fact.
Yeah.
Because there's very little people that are like, what is this Relay thing I hear of? It makes everything hard. Let me use that.
Yeah.
Right?
Yeah, and then it's I guess like the scenario that you probably have at Teams to some extent as well. Like you have a big application. It is complex. It has a lot of moving parts. It has a lot of data. And then you're like, okay, re-rendering only happens from the root. There's like no way to solve this in the same way without actually trying to break things down and moving where the re-rendering is happening. And that's typically like when people realize that, oh, and then you as a Relay developer kind of like don't really get it at first. Like, is this a problem? Like, just make a fragment, I guess.
That's an interesting thing, because so what happens, like also in teams, but I think more often is in a purist way, you kind of don't want to have these things like GraphQL details bleed into your component, right? Like, so a lot of the team's components follow this container renderer pattern, where the renderer component is the root of the actual UI tree, and it is entirely agnostic to how the data gets delivered to it. It's just using React props, TypeScript interfaces, and then internally it disperses the data through React props and use memo, etc. And then the container is the component that is responsible for fetching the data, right? So the notion of inserting these GraphQL documents into each component and basically making every component a container, that's how it kind of feels wrong at some levels, right? Like I would say, knowing from experience what it leads to, I would say like set yourself free and embrace it. But I totally understand that it feels wrong, and this awkwardness is often I definitely feel it around testing, for instance, right? Like when you're testing a component, you kind of like the promise of a pure function is kind of nice, right? And that tends to be a little harder when you start letting some of these frameworks bleed into your code. Nowadays, I would say that's why it's like something like mock payload generator, I think, is entirely correct. Like you shouldn't even think about these things. You should just let the framework do the work for you. Why are you manually crafting payloads when we know the schema and exactly what it needs? But before that it existed, right? You had to then come up with tooling to solve that. And so, there's definitely, I understand that wanting to not have that bleed into every component from that perspective. But I would say we're developing a application that does need these characteristics from the framework. So at some point, making everything abstract and generic you pay a price for that too. And so, in application code, there are places where it makes sense, I think, to be a little less purist about that. Now, having said that, I do think that, and we are looking at some of that, there's a place for, again, treating GraphQL purely as a conceptual thing. Like, there's no reason why we can't generate. Let's say you have a component with a fragment, right? Like, we can just generate a TypeScript interface from that fragment, and then have the component just render with React props that adhere to that interface, right? But then, if you want to, you can compose that component into a GraphQL backed tree. If you don't want to, then you can just give it React props. So I don't, in my mind, using a GraphQL fragment doesn't necessarily need to be tied then at runtime to a GraphQL execution engine or whatever. But obviously that is how it is. That's how you would quickly view it. If you see a GraphQL fragment inside the file, and then you're probably gonna be using it in a GraphQL powered system, right? It's I mean, again, thinking about GraphQL as a contract that allows us to express the data requirements and express the promise of what data the host will make available, does not necessarily imply that we need to actually execute GraphQL at runtime.
Exactly. Yeah. It's nice to think of it as both something that lends itself well to how well component-driven development or whatever works, like with fragments and whatnot, but also like thinking of GraphQL as just a pretty nice way to model your domain as a contract, like how do things fit together, what can things be, and then smearing that onto the actual thing that's pulling out data from it and rendering it.
Yeah,
it's quite I like that. I really like, because I agree with you that, and I guess that's natural as well, but the focus is really on like GraphQL it's almost like GraphQL is the request you make via HTTP to your server. That is GraphQL.
Exactly.
which isn't at all true. Which is also quite fascinating that you're kind of doing the Svelte thing, but for servers, kind of compiling away the framework. But really interesting approach. I've dabbled a bit with building local GraphQL servers just to do exactly what you're describing, like pulling data together from several different sources, but maybe inlining it into your React Native app, because it's terrible to put out updates to React Native and whatnot. So and I think it's also having that easily, or working on getting that a bit more developer friendly, would be a huge service to Relay as well, because Relay doesn't play very nice. I don't think any GraphQL client plays really nice with having multiple schemas and multiple sources of data and whatnot, but Relay especially doesn't play very nice with it. So if it's more about piecing together your own kind of graph locally with that's suited to your specific application, that's, I think, a pretty big step forward when you can afford it, performance-wise, of course. Like, you can do that in a desktop app and whatnot. Might be harder for certain types of projects, but for those that can, it's
exactly. I think there is that playing field is still very, like, there's a lot of low-hanging fruit. There's lots to explore there. As soon as we just for a minute let go of the notion that, like you said, like this idea that, well, GraphQL obviously is a request over a transport, but in reality, let's be real, it's always going to be HTTP. And of course, you want your GraphQL schema to live on the server, right? Like, once we let go of these things, then we can go back to the, like, GraphQL as a spec and see different, like, I think there's a lot still to be done in that area.
Yeah. And looping back to Relay, I know my view, and I know a lot of other people in the community's view, is that Relay is just a really nice way to, it just makes sense for modeling your UI, kind of. Then there's, like you said also in the beginning, there are a ton of specifications and opinions and whatnot, but just having data, modeling your components and your UI in a composable way, like Relay and React lets you do together, it's just a very nice way, regardless of what's backing it, kind of. Even if that's GraphQL, if that would be anything else, it just kind of makes sense, I think.
I agree, but I would say also, if you're using it in, let's assume that in this case that you're using it in React, for instance, then that is the whole idea, having components that you can compose. So it is kind of awkward to then not do your data requirements the same way, right? It's just like, it would be weird for somebody to tell me, like, well, I agree that the UI should be components and composable, but not the data fetching for it. Right? Like, I can understand if people are like, well, no, components are just wrong and we shouldn't do it that way.
Yeah.
Sure. But then if we have components, then that's typically what I explain to people when I show this system for the first time, right? It's like, your fragments will be composed, your documents, GraphQL documents will be composed exactly how your React components are composed. They are the same thing, the same tree, right? So
you pretty much need to buy into that if you're buying into the components.
Yeah. Unless you're going to have components.
Go back to MVC or whatnot. Otherwise,
single component application.
Yeah, which is fine too. Like, if you enjoy that, do that. But
yeah, I mean, it might be more performant.
Yeah. So wrapping up a bit here, like, what's next for you in this endeavor around working with the Apollo client and teams? And you're currently this project is progressing as you'd hoped, and they are doing like benchmarks and whatnot and investigating the performance. So far, it's looking good.
Yeah.
Is it about like
next in the pipeline is wrapping up the API service that we need. So that means I still need to finish off a use pagination fragment, and then that should be enough for the existing product code to be further fragmentized. we are doing that. We're doing that in a we're hand-holding fashion first, but then afterwards, if that all pans out as we want, then all the product teams will take on the work of doing fragmentizing their own product code. I will then want to look at live queries, definitely. Like I said, I think subscriptions are kind of awkward in a lot of applications, but definitely in ours, where we have a local schema. So that will be interesting because we'll need a customized GraphQL schema execution, and so that's more where I really want to be working on in the more future looking stuff. Also, just in general at Microsoft, I think that's like we're slowly building out a wider understanding among the component and host application builders about how we would like the GraphQL to be used within these componentized UI systems, and that's a long running effort. Changing things at this scale, as us people at Facebook and Microsoft like to,
scale.
It's just a monumentous task. So months can pass by with seemingly very little changes, but we're talking about things like a shared schema across all the M365 applications, and then shared components across these applications. And some of them might, and again, GraphQL as a contract, like some of the host applications might resolve the data in very different ways than other applications might. Some might be using remote GraphQL servers, some might be using a local. The point is just that the components just say with their fragments, this is the data we need. And you host application serve this shared schema. So you promise me that I will get this data, and then how you serve it to me, figure it out. And so that's the nice thing there. And I think once we have that ball rolling further, then Microsoft will finally really be able to contribute in that area. Like Microsoft is doing great things when it comes to GraphQL. Like we have as Azure has just launched a service where you can easily add authorization to your schema and whatnot without having to do that yourself as a proxy. But I think in the sense of like putting a mark on how we leverage the core concepts of GraphQL, like what made GraphQL great and how it was designed originally by Facebook. Like that stuff is still in its infancy. There's a lot of too often GraphQL gets approached from the, in my opinion, from the backend perspective, from the programmatic perspective of how can we regenerate schemas from schemas? How can we just pass on data? We just want to unify the query interface. Like we want everything to be queryable through GraphQL, but it doesn't necessarily mean it's a unified schema in any sense, right? Those type of things. So that we have still a lot to do in that area, but I think we're chipping away on that.
Well, since we talked about scale, I understand you probably can't comment on it, but could you say anything about the scale of like Microsoft Teams, versus like the code base itself? Like, does the JS compiler from Relay suffice, or is it too slow to use?
Well, no, the JS compiler works. The first boot takes a little bit. It does build caching, right? So. Afterwards, it's pretty fast. I think the Rust compiler obviously will make a big difference there, but the Rust compiler also would make it right now a little harder to easy experiment with these things that we are putting the Relay compiler through.
It won't give you any graphical JS ASD for a while.
Yeah, exactly. So we'll definitely be looking at that in the future, right? With some of these things that we're doing with the compiling. GraphQL execution to static functions. is not something we're interested in just in the JavaScript space. I can imagine we would compile to Rust at some point. But in terms of size, I mean, it's big. It is big. I don't know how many. I've never run any statistics on how many components exist, but it is very large. Anytime that you use Teams, there's probably a plethora of features that you have never used, have never seen before.
Yeah.
And also in terms of team size, it's like, for me, there's a never-ending stream of people I get to work with, because I don't know actually how many there are.
They just keep coming.
It seems so, and there's so many people doing so much stuff all around the world. Like right now, there's multiple time zones. There's people just chipping away on stuff for Teams. It's huge. It's really huge.
Yeah.
I mean, it's not Facebook.com probably in the sense that everything is a single application, but Teams is quite huge.
It's larger than Artsy, I think it.
It's by a few components, yeah.
By a few components. True. Nice. And a few team members, perhaps, as well.
Right. Well, but it is still, every now and then I go, because obviously the Artsy front-end code base is open source as well.
Yep.
So every now and then I still go into there, and I see the artifacts directory grow and grow, and it's nice. Like it's a system that works, and it keeps working.
Yeah. Awesome. Well, do you have any parting words you'd like to say?
Yeah, no, I mean, I think for whatever main topic we had, I would just reiterate that the various clients are definitely Relay and Apollo are good clients from their own perspectives. They just have different origins and goals and whatnot, and as long as you understand those, then you can hopefully make the right decision for which one you need. Like, there's definitely people I would say, like, your project and you do not need Relay, and you might be making it harder for yourself, and vice versa. So it's all nuances. It's boring. I'm an old guy, but
no silver bullets. Blah, blah, blah.
Yeah, no, it's all good stuff in their own right.
Yeah.
It just sometimes you don't necessarily upfront realize the type of things you'll be facing in the future, and that's not something that's easily fixed.
I think you said it well in the beginning. With it's not apples to apples comparison. Like it's two pretty different things with different goals and different backing, and
yeah, exactly.
And it's because it's so easy to think of it as a apples to apples comparison. It's one client versus another client. Yeah. But that's mostly probably because the knowledge around Relay is quite. There's not too much knowledge around Relay still, because it's quite in the dark.
Yeah.
Well, I thought this was fantastic. It's really refreshing to get a view on both what it takes to, or what are the pieces you pull out of the raisins you put out of the cake, so to speak, from Relay when you sit down and have a look at something at that scale with the concrete kind of problems that seem to be around, and what can we apply to fix this. Also, what goes into the things you've done with the compiler, and figuring out how you can, we can just emit another type of IR, whatever you want to call it, AST. We can do the same work through the compiler fairly easily, by it gives us what we need, and apply that thing, and then also pulling out replicating the fragment subscriptions, but via the watch query and your clever thing about the node interface and how you solve fragments. And also a personal favorite was really hearing about the fact that you compile away the GraphQL execution. That is really neat. I haven't even thought about that before, but of course, that makes sense.
It's really, also in the Gravitation repo. It's called Supermassive.
That'll be my evening reading, probably there.
Yeah, you should. I should hook you up with Michael, because he probably has a branch that is more up to date. But eventually, everything will be there. It's Supermassive. Yeah.
Really cool. Well, I'd like to say thanks again for coming on.
Thank you as well for having me. And
Yeah.
until next time, I guess.
Yeah, we'll see when number 3 is. Maybe when the entire project is shipped and whatnot.
Yeah. That's always good to come back and actually show if it everything worked as we wanted to. And the live story stuff will be interesting.
Yeah, exactly. And if you ever get around to actually like benchmarking between, if that ends up being a viable thing to do, that would be really interesting to hear as well. But also, like, again, it's interesting to just hear about the types of things that you can apply on this scale in order to kind of nudge it. Yeah, there are a few concrete things that are really wins, like that you can apply.
Yep.
So thank you very much, and thank you everyone for watching. And until next time, have a nice evening. Goodbye.